All right, so out of the box, this view controller doesn't do anything, and that's pretty consistent with the demo we saw, right? Before I dragged and dropped anything, it didn't do anything. It's because there's no code here, or nothing interesting, at least in the .h file. But what is interesting is that view controller descends from a standard class, UI view controller. So Apple could have called view controller foo, or just controller, but it's just their habit of calling it a view controller. So let's look at the M file for the view controller class. So again, this is like your index.php in CodeIgniter, or rather the controllers you yourself wrote in your controllers folder. So here now is viewcontroller.m, and out of the box there's a little bit of code here, so let's see what's going on. So first it imports its header file. This is not all that interesting. There's this, which frankly is a little annoying of Apple. You can, with that feature called, what do the parentheses imply? Categories. You can actually have additional private methods and private properties, and they can go inside of the lines I've highlighted. So when you declare a category with no name, the jargon here is that you're making a class extension by not so much adding new functionality to the class, but hiding functionality. Because notice, where are we? We're in the .m file. That means if other people include my code, they won't see anything I write in the highlighted lines here. So for now, I'm actually going to hit delete in a moment, and we're just going to ignore this detail for now. But just realize this is a new convention in iOS of creating effectively private methods and or private properties without using the @private keyword. But without, let's not overwhelm just yet. Let me just delete that, and we'll come back to it eventually. So here now is the implementation of the class called viewController. Now, none of these three methods, and I see there are three because there's three hyphens, none of these were declared in the H file. Recall the H file had nothing in it. So where did the declarations of these three methods come from? The parent class. Right? So we've seen this before. Just as we didn't declare the init method explicitly because NSObject took care of that for us, same deal here. UI viewController is my parent. He's probably declared these various methods. And I could confirm as much. If I Google UI view controller, I'll see a huge list of all of his methods. And I'm simply overriding three of them here. So view did load. What's nice here is that these methods pretty much do what they say. View did load means that you're at the point in your program where whatever you've drawn, say in the nib file, the little stupid hello text and the purple background, that has loaded and is visible now. So this method is called as soon as that happens. And that's useful because you might want to tweak the user interface. I might want to change hi to bye or something like that. This is your opportunity once your nib file has been loaded to do some stuff. View did unload is the opposite. Maybe when the view disappears, you want to free some memory, although that's not something you need to do so manually anymore. Maybe you want to close a database connection or log something. Whenever that screen disappears, you can do something. So this is essentially like an event that gets triggered, much like in JavaScript, if familiar. And now this is a crazy named one. Should auto-rotate to interface orientation? Remarkably, this does what it says. This is a method that's supposed to return yes or no, true or false, if the device should be allowed to rotate to the specified argument. The argument is actually a constant. So UI interface orientation is an enum, I believe. And an enum, recall, is just a comma-separated list of constants. So what this default return value is saying is return interface orientation, which is the argument. It's big font, so it's wrapping onto two lines, but it belongs over there. So if it's not equal to UI interface orientation portrait upside down, return true. So logically, return yes. So this one-liner is saying, let the app work like this, like this, like this, but not like this. So in other words, return no if the user has the thing freaking upside down completely, but it's OK if they have it in any of the three other orientations. This is just a common Apple thing. Like they just want the button at the bottom or the sides. They don't want it completely upside down. But we can override that convention by just returning always yes, literally. So this is just a method that essentially what's going to happen is when the user has the device in his or her hand and rotates it, this method's going to get called, going to get called, going to get called. And anytime it returns true, the UI will actually rotate. Anytime it returns false, it's going to stay where it is. So this is why if you have some games or other applications, sometimes it'll rotate, but if you go too far, it just won't until you go another 46 or so degrees. Then it'll flip around further. So this is just an example of what you get by having your controller class descend from some fancier thing that Apple wrote that has some built-in functionality. Frankly, it would be annoying if you and I had to figure out the geometry and mathematics of rotating the screen. So these are the kinds of shoulders that we can stand on. Now, as for these two methods, notice that the only thing ViewDidLoad and ViewDidUnload are doing are calling the superclasses equivalently named method. That means, for those less familiar with OOP, object-oriented programming, I can actually get rid of that. Because if I don't override the parent class's methods, they will just get called automatically. The reason that I have to call super is because if I do want to override them, the convention is I better at least commit to the parent still doing whatever it wants to do, then do my stuff. But if I don't have any actual work to do, which I don't in my silly purple application, then I can just delete these altogether. There's no value of overriding those methods. All right, so I'm just going to delete that just to simplify the template for now, even though there's no functional change. Well, the last file to look at is appdelegate.m. So let me go into the M file here, and let's see what's in here. Unfortunately, this one's a little more overwhelming, but thankfully it's all comments, so we're about to hit delete again. So here we go. In appdelegate.m is the implementation of my application delegate, the thing that's in charge of my application, the thing to whom what function hands off control. Quick sanity check. Main. Main effectively hands off control to an object of this class. All right, so this class is doing what? Well, it's importing its header file. That's normal. It's importing the view controller. That's normal if it's going to mention it down below. Here comes the implementation of this class. Notice you don't mention the parent class in the M file. You only mention it in the header file with the colon. Now, synthesize, this is like pre-break stuff, right? I'm just synthesizing the window and the view controller properties. And now we have a method called application did finish launching with options. Okay, takes two arguments, application and launch. And this, remarkably, this is really the method that kicks off things. When the app delegate is handed control, once everything's loaded from the flash memory in the iOS device, this is the method that's called, so you can start doing your thing. You can start creating your user interface, either via a nib or manually via a whole bunch of method calls. This is where you can load a database. This is where you can draw a picture on the screen that says like loading ... This is where you have an opportunity to get your application started with any startup tasks that you might have. So this template is doing a whole bunch of stuff for us. That's why I was able to run it out of the box. So what's it doing? Well, first, it's assigning to itself its window property, which recall is just a pointer initially, a nil pointer. It's allocating a UI window, whatever that is. For now, it's a big rectangle that fills the screen. It's a special view. I'm allocating it. I'm initializing it with a frame. What do I mean by frame? Well, I keep saying it's a rectangle, but iOS devices have different dimensions. So I better dynamically figure out what those dimensions are. I can do that. I can ask the UI screen, which is a special class that refers to the glass, really. Give me your main screen. This refers to the actual glass. You might know that you can mirror screens now with like a VGA cable or with an Apple TV. So there might be a second screen elsewhere. So main screen just refers to the glass. And then give me your bounds. Give me your X, Y, top, bottom, that kind of bounds, so that I can say, have the UI window fill the frame, the entire rectangle of the screen, however many pixels or points that is. All right, so that's all it does. The next line is just a comment. This is Apple saying, OK, put your code here. But we're going to ignore that, and let's move on to the next line here. What am I doing next? Well, as the app delegate, I want to adhere to, really by convention, the whole MVC architecture. So to do that, I need a controller. And I maybe need a model, and I probably need a view, but I at least need a controller. App delegate is not a controller. This is sort of, the app delegate exists independent of the whole concept of MVC. But it's up to him to create a situation in which we have an MVC architecture. So he's going to create a view controller object with alloc. He's going to initialize it with the nib whose name is viewcontroller.xib. By default, it's implied. So what does this mean? This means that it's going to create this object of type view controller, and it's going to tell him what file to use to pre-populate its default view. So there's a little commingling of of C and V here, but ultimately the thing in charge of the view is the controller. So this is creating a controller, and it's handing him a default view that's ultimately going to fill the screen. All right, and it's storing it in my view controller property. And the bundle, this just refers to where on disk I can store stuff related to this. A little more than that, but for now, nil is fine. All right, any questions conceptually on these two lines of code? Don't get lost yet. Yeah?
UI in it with frame, can you have it like change the bounds so that you only have like a half screen on your app?
Good question. Can you change the bounds of the UI window so it only takes up half the app? You could, but you wouldn't for the UI window. The UI window is really meant to fill the window. Instead, after creating the window, you would create two children of the window. One is a UI view that's half of it, and the other might be the second half. But those are going to be attached to the bigger UI window, just so you have access to everything.